Still in 1.6. Limits at infinity. We already talked about it a little bit, but I want to kind of go over some of the finer points of it. How do you figure out what the limit is at infinity? Well, on this question here, it's probably best to foil out. Now, some of you are going to start to realize there's a shortcut to this, and you're going to do it a lot faster, but I'm just going to kind of grind it out, okay? Obviously, you can do this faster. Don't think that you have to do it this slow way. So you FOIL it out, 15x squared plus 9 minus 5 plus 4x minus 3 divided by 8x squared minus 2 minus 12 is minus 14x plus 3. Okay? And then, now, most of you know a shortcut to this, but here's the actual mathematical thing you do. You divide by the highest power, right? Okay. Now, if you don't know that, you just learned something. Divide by the highest power. So the highest power is x squared, so you divide everything by x squared. And as long as you divide x squared by the top and the bottom, everybody's happy, right? So what happens then? You get 15 plus 4 over x minus 3 over x squared, 8 minus 14 over x plus 3 over x squared. But remember, where's x going? X is going to like infinity, right? So you're dividing by infinity, right? So when you divide by like a billion, 1 billionth, you know, divide by a trillion, 1 trillionth, it's going to 0, right? So if you start putting a bigger number, 14 divided by a big number, these are all going to 0 then. So what you end up with then as your answer is 15 over 8. Now, again, I think some of you already know this, but if you don't, there's a shortcut to this. You know, what you basically realize is when there's powers, the highest power wins, right? That's now what does winning mean? Well, what happens with highest power wins? The only things that matter, these are going to go away. So what does that mean? Back in the original question, you only needed to actually FOIL out. And you don't even need the x squared because it's going to cancel, right? You get the 15/8. Okay. So pretty easy on that. Now, what if, just hypothetically, and we're going to talk more about this in a minute, what if the power was higher on the top than the bottom, or what? I'm going to oversimplify this for infinity. What if the power was higher on the bottom? I'm just going to use like the most simplest probable case you can come up with this. Instead of making whole polynomials, just making it, well, that's just going to be x, and that's just going to be 1 over x. If the higher power is on top, it's going to go to infinity. If the higher power is on the bottom, it's going to go to 0. It's generally more interesting and more likely to see questions where the power is exactly the same, so you start getting these nice fractions, okay? So, limits at infinity. Now, this is also called the horizontal asymptote. So this will have a horizontal asymptote of 15 over 8. This would have a horizontal asymptote of 0, which would be the y equals 0, which would be the x-axis. That's not an asymptote, it's going off to infinity and beyond. That wouldn't count. That would, you know, there's no such thing as y equals infinity. But just make sure that's how we talked about limits at infinity before when we were talking about how to determine horizontal asymptotes. So we're going to come back to that in a minute. Along this line here, one thing you want to realize quickly in this class, because it will make the math go a lot faster if you figure this stuff out. There's an order at infinity. There's an order of power. Okay, kind of like when we did over here, where we said higher power wins. There's an order to this power. And what do I mean by that? Exponentials grow way faster than polynomials, and polynomials grow way faster than logarithms. So the farther you go out, what's going to happen is exponentials are going to win. They're going to approach infinity way faster than the other thing is. So relatively speaking, the other thing is going to be zero, for lack of a better way of saying it. So here's the idea. This way you can do these limits at infinity really quickly. Exponentials grow faster than polynomials. So this is going to go to infinity because the one going to infinity is on top. Exponentials grow faster than logarithms. Since the exponent's on the bottom's going to go to infinity. That means the whole thing's going to go to 0. Okay? Now, I threw a sign in there just to be silly. Okay? Sign is the totally whippiest of them all. It's sitting here going between 1 and -1. So anything beats a sine wave, right? Because the most sine can ever be is 1, and these are going off to frickin' infinity. They're all going off to infinity in some fashion, right? So that's going to be like something divided by infinity, so that's going to be 0. So I just threw the sign in there just to be silly. And then here, polynomials beat logarithms. So the infinity is on top, so it's going to infinity. So if the one that wins, if the one that wins is on top, it's going to go to infinity. If the one that wins is on the bottom, it's going to go to 0. That's just kind of a shortcut idea. Now, I did want to end with something that doesn't happen very often, but it happens enough that we have to talk about it, okay? Limits at infinity is another name for horizontal asymptote. It's really plus or minus infinity. So really, I also should check negative infinity here if I want to actually check to make sure. But notice that it doesn't matter whether, if this goes to infinity or negative infinity, they're still going to go to 0. Signs would change, but it's still going to be the same. And that's usually what happens. So you might be wondering, when would it not happen? Well, let's talk about this. This came up on an AP question like 10 years ago. I'm not kidding. I want to say 2011 or something like that. Maybe it might have been as late as 2014, something like that. Where the AP asked this question, and what happened was, and I'm not making this up. So many people missed the question that they actually threw it off the test. And I've been teaching AP Calc for 25 years. That's the only time I've ever seen them throw a question off the test. And you know what they were? They were mad at us, the teachers. They said, you guys kept teaching horizontal asymptote. It was just positive infinity. You never had them checking the negative infinity. So what they actually realized was, why they threw it off the test was a lot of people who got a 5 on the AP exam that year missed that question. So they said, wait a minute, if all the really good students are missing this question, then that's on the teachers, okay? And so here's the deal. This last example is just to make sure I cover my bases here, because this doesn't happen that often. Normally a horizontal asymptote is the same for positive or negative infinity. Normally it is, there's no doubt, okay? Sometimes it's going to create 2 different asymptotic lines. Sometimes. Sometimes it creates one. It has a different asymptotic line than the other one going out to negative infinity. And I want to do an example of that, okay? So, if I go out to infinity, notice the 1 and the 5 won't matter here, because that, like, we know that, like, exponentials are like the gods of going to infinity, right? They go to infinity, like, they're huge, right? So, what you want to say to yourself is, well, that's basically 3 to the x over 3 to the x, which is 3 to the, 1 to the x. You can pull the exponent out if you want, or you can just, either way, you're going to get 1, right? You're going to say, okay, well, so if I go out to infinity, 3 to the infinity is going to be some just ridiculously big number, so who cares if you had 5 or you had 1, so they're not going to matter, right? So, or you could do what we did before, and divide through by the 3 to the x, by the highest power. You can divide through by that, and you get 1 divided by 1 over 3 to the x, and then you get 1 divided by 5 over 3 to the x, and these are going to go to 0. But anyway you think about it, it's going to go to 0. Now, here's the thing. This is the kind of question they asked on the AP exam that year. They didn't ask for this positive, they asked for the horizontal asymptotes. So one horizontal asymptote would be y equals 1. The other one, and that's what everybody wrote for the answer. Nobody bothered to check the negative infinity because, you know what, we don't really do that very often. The AP was just being kind of jerky in my opinion, but philosophically correct. We should talk about negative. Now remember, when you go to negative, remember what exponentials look like. Remember what they look like, right? They go off to infinity here, no doubt, right? You know, y is approaching infinity over here, right? Over here, though, they're getting close to 0, aren't they? So you have to notice that, an exponential, that's going to be 0 plus 1, 0 plus 5. Which one? Now, that's how I think about it. Just graphically in my head, I realize that this is the exponential wave here. So it's approaching, y is approaching 0 on this end. It's approaching infinity on that end. What you can do, if you like, is if you want to actually think about it, I'm going to give you another way to think about it. 3 to the negative infinity, plus 1 plus 5. Remember, the negative means it's really downstairs, right? It's really downstairs. 1 over, right, like if you have 2 to the negative 7, that's 1 over 2 to the 7th, right? Right. So, and then that's going to infinity, so these are zeros. Oh, that's supposed to be a 5. But in any way you think about it, 3 to the negative infinity is really a almost 0 number. So here's the deal. So when you put that in 1 over 5, let me finish this up. I didn't finish, sorry about that. Y equals 1/5. So the answer to the question is there are 2 asymptotic lines. One from the left and one from the, one off the left, there's an asymptotic line of 1/5 on one side, and then on the other side there's an asymptotic line of 1 if you were to graph this function. It has 2 asymptotic lines. Okay, and that, that's just because, the AP exam made a big deal about that a while ago. And now, I'll be honest with you, now that they did do that, they actually often put a question where the horizontal asymptote has like approaching 1 on one side, and then in this case like 1/5 on the other side. So be aware that that is something that does happen. Anyways, this is called limits at infinity, and just be careful, we have to also talk about negative infinity. Usually they're the same, okay? One of the things you want to realize is when you're going out to infinity, there's some big deals here, like the logarithms do not grow as fast as polynomials, and polynomials do not grow as fast as exponentials, so you can actually do them very quickly. We're going to show you another mathematical way to do it, and we'll learn something called the Hoppe-Tall's rule later on, and we can verify that I'm not making this up. Although I think the graph's pretty clear that I'm not making it up. And then last but not least, this idea that you do need to check for horizontal and vertical asymptotic lines. Okay, 1 second. Okay, I think we have one more, the next lesson is going to be like part 1.6 and 1.8 on piecewise functions, okay? We're getting close to finishing 1.6.